Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on compound interest. So it turns out compound interest is a type of exponential growth. So let's look at this example here. I invest $2,000 at 5% per annum. And remember, per annum means per year. So I would get 5% interest each year that I invest this money. I leave it in the bank account. So you've done simple interest before. So if this was simple interest, because 5% of 200 is $100, your amount in your account would just go up by $100 each year. So if you start with 2,000, you would have at the end of the first year 2,100, and at the end of the second year you'd have 2,200, at the end of the third year you'd have 2,300, and so on. But compound interest, that is exponential growth, and hopefully you know by now this means that the amount by which your account would increase each year goes up each year. What does that actually mean? So if it was compound interest, well, you'd still start with $2,000. And at the end of the first year, like simple interest, you'd still have $2,100. But what compound interest does is it says at the end of the first year, we're not going to earn 5% of the original amount, 2,000. We're going to earn 5% of 2,100. And that actually is 105. So your account would go up by 105 this year. So then at the end of the second year, it would say, okay, it's not 5% of 2,000 that you earn. You'd earn 5% of 2,205 in this year. So your account would actually go up by 112.50. So you'd have 2,317.50. So whereas for simple interest, you just go up by 100 each time, compound interest, the amount you have is increasing at an increasing rate. Now, because compound interest is an example of exponential growth, we can just use the formula that we went through last time. So on your screen in blue is the formula for exponential growth we looked at in a previous lesson. So we can use this formula, they'll just have slightly different meanings. So here, P, remember, is the initial amount. So when we're talking interest, we call that the principal. So here, R is still the rate as a percent, and it's the rate per period. So N is the number of increases, or the number of periods, if you like. And A is usually what you're trying to find. Not always, though. A is just the amount. So we're going to use this exact same formula to calculate compound interest. Now, there's just something that makes this a little more complicated, which I'll go through in a second. But first, let's do a very quick example. So if I invest $2,000 at 5% per annum, which was the example on the previous slide, how much money would I have after 15 years? Of course, I don't want to calculate the amount after year 1, year 2, year 3, all the way up to year 15. That will take too long. So the amount I will have is going to be how much I started with, the 2,000, times 1 plus rate over 100, to the power of 15, because there are 15 periods, 15 years, 15 increases. So putting that in our calculator, and I'll just give it to the nearest dollar, it's about 4,158. So if this was simple interest, remember it was going up by 100 each year, I would have had 3,500. So you end up with a lot more money with compound interest. Now, the thing that makes compound interest a little more difficult is I actually haven't given you all the information. See, this is the amount we get if we did what we did on the previous slide. That is, remember on the previous slide, we recalculated how much interest was earned at the end of each year. We did it at the end of year 1, year 2, year 3. But it doesn't have to be like that. A bank can recalculate how much interest you earn at the end of every month, or the end of every year, or the end of every fortnight, or whatever. So that is called the compound period. Here, I actually calculated how much money we'd have if interest was compounded annually, if we recalculated the amount of interest owed at the end of each year. So this is the answer we would have got if on the previous slide we kept going year 4, year 5, year 6, all the way up to year 15. But what if we didn't? What if we calculated it monthly rather than annually? So if the interest was recalculated at the end of each month, what we would have to do is a little bit of work before we can use this formula. We would have to change R and N to be in the same units. So when I say that R and N must be in the same unit as the frequency of compounds, if the frequency of compounds is monthly, if interest is recalculated at the end of each month, then R needs to be the rate per month and N needs to be the number of months. So in this case, we had R was 5% per annum. So to make that per month, we just need to divide by 12. So R would be just 5 over 12% per month. So N, so we're talking 15 years, we need to put N in months. So 15 years, to make that into months, you just go 15 times 12, which is 180. And of course, that's because there are 180 months in 15 years. So if it was compounded monthly, this is the formula we'd use. We'd go A equals 2,000. The initial amount's still the same, but R we'd change to 5 over 12. So it's R over 100 to the power of N, like this. So if I now put all of this on my calculator, again, I'll do it to the nearest dollar, I get about 4,227. So you can see if interest was compounded monthly, I have slightly more money in my account than when it was compounded annually. And that's no fluke. That happens all the time. If you keep the initial amount and interest rate the same, the more frequent the compounds, the more often you recalculate the interest, the more money you'd have. So if this was, say, compounded daily, I'd have a little bit more than this still. So just make sure when we're doing compound interest questions, you can use the same formula for exponential growth, but you must make sure R and N are in the same units as the frequency of compounds. So if it's compounded like quarterly rather than monthly, then the interest rate needs to be changed to per quarter and the time needs to be changed to the number of quarters. If it's per fortnight, R needs to be changed to rate per fortnight and N needs to be changed to the number of fortnights. So you may have to change R and N for compound interest questions, whereas we didn't in other exponential growth questions. All right, I'm just going to do one more example now where we're finding the initial amount. So let's look at this question here. A bank offers 12% per annum interest compounded annually. How much would I need to invest in order to have 10,000 in my account after 5 years? So this is the formula for compound interest. You've just got to figure out which letter are we actually trying to find. So here we're actually told 10,000, we're told A. That's the amount I'll have at a given time, in this case in 5 years. So we're not told how much we started with. We're not told how much I originally invested. That's what the question's asking. How much would I need to invest? So here I'm told A, 10,000, but I'm not told P. So this question's different. In the previous questions, we were finding A. We knew P. Now it's the other way around. We don't know P, we're trying to find P when we know A. So what we can do is substitute everything we do know. So I'm going to substitute A for 10,000, P I don't know. I'm going to substitute R for 12 and N for 5. Now in this case, I don't need to change R and N because the compound is annually per year, R is per year, N is per year already, so no change needs to be made. So of course I would need to make a change if it said it was compounded monthly. Then I need to change this to per month and this to number of months, but I don't need to do that here because it's compounded annually. All right, so I got my equation here. I want to find P. All I need to do is take this number and divide by this. Hopefully, it's stuck in your head now. If you are trying to find the initial amount, all you do is divide the amount by the relevant percentage. So this is what P, the initial amount, is going to be. Whenever you're trying to find the initial amount in a percentage question, you always divide rather than times. So if you put that on your calculator again, I'll just give it to the nearest dollar. You get about 5674. I would need to invest $5,674 at 12% per annum compounded annually. If I did that, I would have $10,000 after 5 years. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.